Hello students, so in this video we are doing the topic straight line. A straight line in class 11th also we have studied, but in class 11 that was straight line in 2 dimensions. So if you remember, in 2 dimensions we had different forms of line, like we had, if you remember, slope intercept form was there, uh, 2 point form was there, equation of line passing through a point with slope was there. So 5 forms were there. Now in class 12 we have line in 3 dimensions. So like the major topic in this is what you have to do is equation of line in space. So that is 3 dimension equation of line in space is a topic. In this we have to do 2 forms are there. So like how it is determined? First cases, a line is uniquely determined if it passes through a given point and has a given direction. And second that we have to do is it passes through 2 points. So 2 forms are there. First is what? It passes through a given point. A point is given, that means the point will be fixed and it has a given direction. So first we will see this formula and then we go to the second one. So like if you just notice this thing 11.3.1, equation of a line through a given point and parallel to a given vector. Some vector b is given. Okay, so the statement says the equation of a line passing through a point A. This is a point A whose position vector is A and it is parallel, the line is parallel to the vector B. The equation of a line passing through the point A, it is a fixed point. Let the coordinates of A be x1, y1 and z1 and position vector of A be equal to, be denoted by this. This is the fixed point. And what else is given? That this line, this is a line, you can see from here. Line is parallel to some vector B, where vector B we can take it as in terms of components AI plus BJ plus CK. This is your vector B, and we have to show that equation of line passing through the fixed point with position vector A and parallel to vector B is given by R is equal to A plus lambda times B. This is the vector form of the line. So this you have to remember it in this. This is a like most questions will be based on this. It is a vector form of the line. Again, what is given in this? In this it says the line passes through a fixed point whose position vector is A. Now position vector already we did in vectors. That is the position of this with respect to a fixed origin. And it is parallel to some vector B. So two things are there. Now what we do is let us take some point P. P is a variable point. So let P, coordinates of P, we take it as x, y, z. Let P be the variable point. That variable point means what? The point moves on the line. So let P be the variable point whose position vector is R. Let P be the variable point with position vector R. Okay. So that means this variable means this point can move along the line, and A is a fixed point with coordinates x1, y1, z1. So now OA can be expressed as in terms of components. If we write, it will be x1i plus y1j. This we have done in vectors. And vector B is AI plus BJ plus CK. Now see, you see in the figure that line L is parallel to vector B. This implies a portion of the line, that is AP, will also be parallel to vector B. AP is a portion of the line, see in the figure, this figure. Now, we have done in vectors, we have done this point in vectors. If two vectors are parallel, then one can be expressed as a scalar multiple of the other. This is the condition for vectors to be parallel. Now, AP can be written as OP minus OA, which is equal to lambda times B. Now, OP is R minus this is, this is what we have taken, this we have taken it as A is equal to lambda times b. So from here we get the equation as a plus lambda. Remember, this is a formula that is mostly used in almost all the questions. This formula will be used, passing through a fixed point and parallel to vector b. Now this is a vector form. Now what we have to do is we have to find its Cartesian equivalent also. So Cartesian equivalent, how do we find it out? For Cartesian equivalent, this equation, if you just look at this equation, okay? In this, we write this in terms of component. So we have the equation r minus a is equal to lambda b. R is xi plus yj plus zk minus a is x1i plus y1j plus z1k is equal to lambda times ai plus bj plus ck. So from this, remember both the forms, Cartesian and vector form. So this will be now, if we write it, this will be x minus x1, grouping the terms, plus y minus y1 j plus z minus z1k is equal to lambda times ai plus bj plus ck. Now equating components on both the sides. When you equate the components on both the sides, what will we get? When we equate the components on both the sides, we will get, I'm just rubbing this portion, equating components on both the sides, we will get x minus x1 will be equal to lambda times a, that is component of I, which implies x minus x1 upon a will be equal to lambda. Similarly, the component j will be y minus y1 is equal to lambda b, which implies y minus y1 upon b is equal to lambda, and z minus z1 is equal to lambda c, which implies z minus z1 upon c is equal to lambda. So from these three, we get the Cartesian form of the line is x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So this is your equation of line in Cartesian form. This is the line in vector form. Just you have to remember, questions can be the vector form is given, you have to write the Cartesian form, or Cartesian form is given, we have to write the vector form. So first we'll see that type of questions. One very important condition is, please note that any question of straight line when you have to solve, please note that one very important condition is any question of straight line, if we have to solve, what you have to remember is, I'm just writing it over here, it is a very important condition. Line should be in standard form. Before doing any question, please note that line should be in standard form. Now, what do you mean by standard form? Like standard form means coefficient of x, y, z should be 1 and positive. Remember that. Okay, I'll write this also. This is a very important condition. Before doing any question of straight line, just check this should be in standard form. Coefficient, otherwise your answer will be wrong. Coefficient of x, y, z should be positive and 1. Right? So now we'll see first question on this. So again, I'll just rub and write the Cartesian and this thing. And you know what? It is line passing through fixed point and parallel to given direction. So again, I'm writing the equations. These two are the equations that we have got finally. The equation is r is equal to A plus lambda B is a vector form, and Cartesian equivalent is x minus x1 upon A, y minus y1 upon B is equal to z minus z1 upon C. Right? These are the equations. And how do we say? We say that this is the equation of line passing through the point x1, y1, z1 with direction ratios A, B, and C. A, B, C are the direction ratios of the line. Right? Because this line is parallel to vector B. So vector B के direction ratios क्या है? Direction ratios of vector B are A, B, and C. And if two lines are parallel, the direction ratios are the same. So this will remember equation of line passing through the fixed point x1, y1, z1 with direction ratios A, B, and C. This is important thing. अब एक formula और यहाँ पे कर लेते हैं. The second form of line is equation of line passing through 2 points. We have equation of line passing through 2 points. Passing through 2 points. Okay. बस ये दो फॉर्मूले हैं. Passing through x1, y1, z1, and next is x2, y2, z2. Now see, this result comes from this equation only. How it comes? We know that what are the direction in vectors. We had done direction ratios of a line joining 2 points is given by x2 minus x1, y2 minus y1, z2 minus z1. They are direction ratios of line joining 2 points. Now ABC are the direction ratios. Equation of line passing through 2 points. यहाँ पे what will come? x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. आपको ये दो फॉर्मूले याद रखना. These are the two formulae of the straight line. So we first thing this formula. Now first we'll see some set of questions. So we move on to the next page. Let us see some questions based on this. Okay, let's see. This is the question. Just look at the solved example. This is the question. See, what does it say? Find the vector and Cartesian equation of line passing through the point 5, 2 and minus 4. Your minus sign is not visible. Find equation of line passing to the point 5 to minus 4 and parallel to vector. Parallel to vector B means B is given to B. यहाँ पे कितना दिया है B? 3i plus 2j minus 8k. Okay, passing through the point. So first I write the Cartesian equivalent. X minus 5 upon 3, y minus 2 upon 2, z plus 4 हो जाएगा upon minus 8. This is a Cartesian form. Clear? अब इसका vector form क्या होगा? Vector form will be R. We write it. These are the points. It will be 5i plus 2j minus 4k plus lambda times b. B is 3i plus 2j minus 8k. This is your Cartesian form. This is a vector form. I hope it is clear. Okay. Now this already I discussed equation of line passing through 2 points. 2 given points means there are 2 points. One point we had taken x1, y1, z1. One is x2, y2, z2. And already from the previous formula we got this. Look at some more questions of the same type. I directly go to the exercise. It will be more clearer there. Shortest distance between the line is important. So we move on to look at this exercise now. In this, what questions are important? First is this perpendicularity condition I'll discuss. First, we see the fourth question. Find equation of line which passes through the point 1, 2, 3 and parallel to the vector. Same type. passes through the point 1, 2, 3, means equation will be x minus 1 upon parallel to this vector 3y minus 2 upon 2, or third point is 3 z minus 3 upon minus 2. This is the Cartesian equation of the line. The vector equivalent of this will be I plus 2j. ये vector equivalent हो गया the point plus lambda times whatever are the direction ratios 3i plus 2j minus 2. I hope it is clear. Okay. Now, next question. Fifth one. Find equation of line in vector and Cartesian form that passes through the point with position vector. अब ये point का position vector दिया है, means what is this point given? ये R1. R1 in terms of component it is given 2i minus j plus 4. अगर ये component है मतलब what is the fixed point? Fixed point is 2 minus 1 comma 4 and parallel to this b is given. So vector equation, so you can directly write this is vector b given minus k. So what is the answer? R is equal to R1 plus lambda times b. R is equal to R1 कितना? Directly you can write the thing 2i minus j plus 4k plus lambda times b is I plus 2j minus k. And what will be the Cartesian equivalent? This is a point given, this is a vector. So Cartesian equivalent will be x minus 2 upon vector का 1 है component, y plus 1 upon 2 z minus 4 upon minus 1. I hope that this is clear to all of you. Now, next is sixth question. Find Cartesian equation of the line which passes to the point and is parallel to this. Now, if two lines are parallel, that means the direction ratios are same. तो यहाँ से आपका point क्या directly we can write x minus 2 upon, since the line is parallel, the direction ratios it will be 3. The point is y minus 4 upon 5 and I think यहाँ पे minus sign is there. It should be z plus 5 upon, since the vectors are, since the lines are parallel. So this is 6. Now see, these type of questions, they come in for MCQ. The Cartesian equation of the line is given. So next question is, the next question says, the Cartesian equation of the line, that is under the 7th question, Cartesian equation of the line is x minus 5 upon 3 is, please note क्या बताया था line के लिए, first important condition is it should be in standard form. Standard form means coefficient of x, y, z should be positive and 1. First we check that they are already positive and 1. Again we can write standard form hota hai x minus 5 upon 3. This is y minus y1, so it should be minus 4 upon 7. And this is z minus 6 upon 2. इसका वेक्टर फॉर्म लिखना है. तो वेक्टर फॉर्म क्या हो जाएगा? r is equal to r1 is a point, that is 5i minus 4j plus 6k plus lambda times 3i plus 7j plus 2k. Clear है? Okay. Now, next question, 8th one. This is 2-point formula. Find vector and Cartesian equation of line that passes through the origin is 1 point and this is the point. क्या फॉर्मूला था हमारे पास? फॉर्मूला वाज x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Now the line passes through the origin. So let origin be x1, y1, z1, and the next point is this. So what we can write? We can write x minus 0 upon 5 minus 0. Okay, this point we can take it as y2 minus y1 is equal to z upon z2 minus z1. X minus 0 upon 5 minus 0. Y minus 0 upon this is minus 2 है यहाँ पे मिसप्रिंट है -2 minus 0. Z minus 0 upon 3 minus 0. Answer is x upon 5 is equal to y upon minus 2 is equal to z upon 3 is the equation in Cartesian form. They are asking also the vector form. Vector form will be what? R is equal to. Now, since the point is the 0i plus 0j plus 0k, lambda times 5i minus 2j plus 3k is the vector form of this. I hope it is clear. Okay. Now, next page, we move on to the next page. Let us see what are the next. Okay. This is now. Find the vector and Cartesian equation of the line passing through 2 points are given 3 2 5. Actually I think ये minus होगा 3 minus 2 minus 5 and 3 minus 2 and 6. So what we can do is x1 y1 z1 is 3 minus 2 minus 5 and the point is x2 y2 z2 is 3 minus 2 and 6. Equation of line, Cartesian and vector both are asking. The first we write Cartesian equation x minus 3x minus x1 upon x2 minus x1. x2 minus x1 is again 3 minus 3. Y minus y1, y this minus 2, again it will become plus 2, it is 0. Z minus z1, that is 5 upon 6 plus 5 हो जाएगा. The answer is x minus 3 upon 0, y plus 2 upon 0, z plus 5 upon 11. If it is minus, if it is positive, accordingly you can check it. This is the Cartesian form. Vector form will be r is equal to 3i. It should be minus 2j because y minus 5 होता है. Minus 2j minus 5k plus lambda times 0i plus 0j plus 11k. This is the answer. I hope it is clear how to write Cartesian and vector form. Now next thing is, if the lines are, say, what are the next things are there? If two lines are given, say, again next set of formulas. So first set we have done, line passing to the point and parallel to the vector. Second set also we have done. Now if the lines are given as first line L1, say denoted by L1. L1 line is x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1. And line L2 is x minus x2 upon a2, y minus y1 upon b2, z minus z1 upon c2. The lines are given. Now, the two lines conditioned for parallel and perpendicular. So what are the conditions? Line L1 is parallel to L2 if their direction ratios are same. That is, condition is A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, right? So this is your condition for parallel lines. And line L1 is perpendicular to L2. Perpendicular to L2, it will be A1, just like vectors, A1, A2 plus these are the conditions. Provided what is important? Line should be in standard. Okay. This is the thing. Now let us see the questions on this. Right now I'll take up this we have done 9. We have this question. Find the value of P so that the lines, first line given here is 1 minus x upon 3 is equal to 7y minus 14 upon 2p is equal to z minus 3 upon 2. And L2 is 7 minus 7x upon 3p y minus 5 upon 1 6 minus z upon 5. What is the question? Find the value of P so that these two lines are perpendicular. Important thing, line should be brought in the standard form, if you remember that. First line, it is not in standard form, we bring it in the standard form, coefficient. So we write it as x minus 1 upon minus 3. From here, 7 has to be taken out. Y minus 2 upon 2p. This term is already a z minus 3 upon 2. Again, this can be written as x minus 1 upon minus 3. This will be y minus 2 upon 2p by 7 and z minus 3 upon 2. Now this is in the standard form. Coefficients of x, y, z are positive and 1. Okay. Similarly, equation number 2. It is also not in standard form. So here what is it coming? Line number 2. 7 can be taken out common. It will be x minus 1 upon 3 minus 3p. This is standard. Coefficient of y is positive and 1. And this also will be now z minus 6 upon minus 5. And this again will be written as x minus 1 upon minus 3p, y minus 1, y minus 5 upon 1, z minus 6 upon minus 5. So now applying the condition, what do we get? A1, A2, that is minus 3 into minus 3p plus 1 into 2p upon 7 plus 2 into minus 5. क्या condition थी? A1, A2 plus B1, B2 plus C1, C2 should be equal to 0. Now you just simplify this and from this you will get the value of. This is an important question. Okay, this is a very important question. The lines, an important thing is that in hurry students tend to forget that line is in the standard form. That is very important. 13th also you can write out. 13th question says show that the lines are perpendicular. Check it, lines are already in the standard form. Yeah, x minus y plus 2z, x, y, z. So directly you have to check whether the lines are perpendicular or not. I hope this much part is clear of about straight line. Now what we are going to do in the next video, I'll just tell you a very important formula about the shortest distance. That is a very, very important one. And that you get a 5-mark questions on that. And some more questions I'll be posting them. Okay. So just practice the questions, whatever two forms of lines are there, summarize it. Parallel condition we have done, perpendicularity condition we have done. And just next video, I'll be just tell you about the remaining thing, that is what are skew lines and what is the shortest distance. Okay. Thank you so much.